Hello everyone. This video will cover 1.5, solving equations. So what we're going to do is we're going to take a look at solving linear equations, and we are also going to look at solving quadratic equations. You should be pretty proficient with solving linear equations by now if you're in pre-calculus. And you really should be proficient in solving quadratic equations, but we could definitely use a review there. So I'll do one example of solving linear equations, but then the rest of the lecture will focus on solving quadratics. Okay, so 1.5, which deals with equations. Okay, so let's start with linear. Okay, so linear equations. So let's do one example just so you have an idea. So maybe you have to solve something like this: 5x minus 13 equals 12 minus 5x. And let me rewrite that one. This looks like a... Okay. All right, so if that looks like a B. Hold on, let me change that one as well. Okay, so I'm going to bring this down here. 5x minus 13 equals 12 minus 5x. Okay, so here we have x's, we have variables on both sides of the equation, so we have to cancel one of them. It doesn't matter which one. So you could either subtract 5x on both sides to cancel the one on the left, or you can add 5x to both sides to cancel the one on the right. Again, it doesn't matter. At the very end, everyone will end up with the same answer. Okay, so I'm going to go ahead and decide to cancel this one over here. So I will add 5x to both sides. Okay, and that will cancel out over here. And that will leave me with 10x on the left minus 13 equals 12. Okay, so now that we have only one variable, 10x over here, we can work to getting that x by itself. So I need to cancel this minus 13. So I will go ahead and do the opposite operation. So I will add 13 to both sides, and that will cancel out the 13 here, leaving me with 10x on the left and 25 on the right. Okay. And then I want to cancel out that multiplication by 10. So the opposite of multiply is divide. So I'm going to divide both sides by 10. Okay. And that will cancel out the 10 here on the left, leaving me with 1x, because 10 divided by 10 is 1. 1x is equal to 25 over 10, which are both divisible by 5, so I can reduce this to 5 over 2. Okay. All right, so that's solving a linear equation. So let's focus on quadratics. We're going to take a look at quadratic equations, and then we're also going to take a look at what's called quadratic in form. Okay, so let's start off with quadratic equations. Okay, so so before we start, quadratic equations are degree 2. So you have something that looks like this. Okay, so that's the type of equation we're going to be looking at on how to solve. So we're going to look at 3 different methods. We're going to be looking at factoring, like we did in the previous section for rationals. Okay, so we're going to be looking at factoring where we do the double parentheses. Okay, that kind of factoring. We're going to take a look at completing the square. We're looking at that method. Okay, and then we're going to look at a third method, which is the quadratic formula. And hopefully you all have the quadratic formula memorized, and you all own a t-shirt that has the quadratic formula on it. If you don't own a t-shirt, you should definitely go online and order one. Okay, so let's take a look at this one. We'll do factoring first. Okay, so factoring. Okay, so let's solve. Let's solve by factoring. And let's suppose that we have this equation. Suppose that I have 2y squared plus 7y plus 3 equals 0. Okay, so if I'm trying to factor this, I need to figure out what times what will give me 2y squared. What times what gives me 2y squared? So we have 2y times 1y. Okay, and that's what gives me this 2y squared. Okay, now I want to make positive 3. Okay, so I need to think, well, what times what will give me positive 3? Okay, so first of all, the signs. We want positive, and there are 2 ways to make positive. Positive, positive, negative, negative. Okay, we look here to the middle to decide which of those are we going to choose, positive, positive, or negative, negative. Okay, so looking at this positive 7 here in the middle, that tells us that we're going to need both signs the same and both of them positive. Okay, if the signs are different, one positive, one negative, then you end up with negative 3. But we don't want negative 3, we want positive 3. Okay, so now we want 1 times 3 or 3 times 1. Okay, so if you can't tell which one it is, just put them down somewhere, and you're going to have to check to see if you get 7 for the middle. Okay, positive 7. Okay, so let's say that I do 1 here and 3 here. Okay, the way you check, so we know we get 2y squared, and we know that we get positive 3. So the question is, do we get positive 7y for the middle? And the way you check is you take the outside product, 2y times 3 is positive 6y. And then you take the inside product, 1 times y is 1y. And then you combine these two products and you check to see if what you get here matches the middle term. And the middle term is right here. And they match. So this is the correct order. Okay, oftentimes students don't check the middle term and they think they factored correctly, but it is not. Okay, so make sure you check that. All right, once you have the correct factors. Then we use the zero property that says, let me just write it over here off to the side if you don't remember. So the zero property states that if something times something equals zero, and it's kind of obvious, right? If A times B equals zero, then one of those has to be zero, right? So either the A is zero or the B is zero, okay? Or maybe both of them are zero, okay? All right, so that's basically what we have here. 2y plus 1 times y plus 3 equals 0. So one of those factors, this factor equals 0, or this factor equals 0. So let's go ahead and write that down. 2y plus 1 equals 0, or y plus 3 equals 0. Okay, and so then we solve each one of these for y. So subtract 1, so 2y equals negative 1, divide by 2, y equals negative 1/2. Okay, so that's one of the answers. Okay, and then solve the other one. So over here, let's subtract 3, both sides. So y equals negative 3. That's your second answer. Okay, so that's how you solve by factoring. You first factor, and then you set your factors equal to 0 and solve each one. Okay. So now let's take a look at solving by completing the square. Completing the square. All right, solving by completing the square. So let's suppose we're trying to solve this problem over here, 2x squared. 2x squared plus 8x plus 1 equals 0. Okay, so if you try to factor this, it's not going to factor out. Okay, so the question is, okay, well, when we're given a quadratic equation to solve and it's not factorable, then how do we solve this? Okay, so one of the ways to solve this, if it's not factorable, is by completing the square. Okay, now I'm going to go ahead and write it down here. Okay, so before you can complete the square, this number here, this leading coefficient, needs to be 1. Okay, so if it's not 1, then we need to make it 1 by dividing everything by that coefficient. So here that coefficient is 2, so I'm going to divide everything here by 2. When I do that, 2 divided by 2 is 1. And that's what we want. We want that leading term to be 1. 8 divided by 2 is 4. 1 divided by 2, I'm going to leave it as a fraction. And 0 divided by 2 is 0. Okay. And what happens here is, so it's not factorable. So what we try to do here is we go ahead and we move this third term right here to the right-hand side. Okay. Because it's like saying this one is not quite working for us. It's not allowing us to factor. So let's go ahead and subtract 1/2 on both sides. Okay, and what we're going to do is we are actually going to find a third term that works for us. Okay, so we have negative 1/2 now on the other side. and we don't have a third term on the left side, okay? So if we're going to be adding this mystery number here on the left-hand side, then we also have to add it here on the right-hand side to keep things equal. Okay, so the big question, how do we find this mystery third term? So this over here, for those of you guys who may have forgotten, to figure this out, you take half of b, okay? So again, this is ax squared plus bx plus c, right? All right, so we're going to take half of b, and then we're going to take that and we're going to square it. Okay, so here in this case, b is 4. So we're going to take half of 4, which is 2. And then we're going to square it, right? Okay, so that becomes 2 squared, right? I'm going to write it as 2 squared over here. All right, so what happens when we take half of b and we square it, we turn this trinomial now into something that is factorable into a perfect square, which is why we call this method completing the square. Okay, so it turns out that this will factor out to x plus whatever this b over 2 term is. Okay, do you see how I got this? This here is just your, this is just your b divided by 2. Not squaring it, just b divided by 2. Okay. All right, so this side we're going to get negative 1/2 plus 4. Okay. All right, let's move this up a little bit more. Okay, so here we get our x plus 2 quantity squared equals to, over here, if we have 4 minus 1/2, that's going to be 3.5 or 7/2. Okay, I'm just going to write it as 7/2. If you want to write it as 3.5, that's fine. Okay, and then at this point here, to get rid of that square, we're going to go ahead and take the square root of both sides. And remember, when we do that here, we end up with 2 answers, a positive and a negative. Okay, when we were talking about square roots previously with numerical square roots, they were talking about the principal square root, in which case you just take the positive answer. But we all know, like if you take the square root of, let's say 16, right? Well, if you're trying to find a number that you can square to give you 16, then that could be positive 4, right? Because 4 times 4 is 16. But it could also be negative 4, because negative 4 times negative 4 is also 16. Okay, so we have these 2 answers here, plus minus the square root of 7/2. This here cancels out the radical. Okay, and so I get x plus 2 equals plus minus the square root of 7/2. And then I solve for x, so I have to subtract 2 on both sides. So I have x on the left-hand side, and over here, I like to put the number first, so I'm going to put negative 2 first, and then my plus minus, and then my radical. Okay, and nothing left to simplify there, so you can just leave your answer like that. Okay, so let's just kind of recap here. Okay, so right here, We, right here in this step, we move that third term because that one is not working for us. It's making this not factorable. Okay, so here we move that third term. So we subtract 1/2 to both sides. And then in this step over here, we find a nice new third term. And we do that by taking half of this number, half of b, and squaring it. So 4 divided by 2 and squaring it. 4 divided by 2 is 2, which is why it says 2 here and 4 divided by 2 over here. Okay. So hopefully that's kind of the key part, how you find this third term. You take half of b and you square it. Okay. And then once you do that, then that becomes factorable to a perfect square. Okay. And then you just do the computation on this side. Okay. And then you cancel out your square root. Your square by doing the square root. Okay. And finish solving for x. Okay. All right. Again, if you have any questions, just message me or email me. Okay. So now we are looking at the third method, which for solving quadratic equations, which is quadratic formula. Okay, so quadratic formula. Do any of you guys know the song? Did some of you just laugh from a not so distant memory of having to sing it in class? Okay. I have a bit of a delay over here, so my cloud didn't quite make it around formula, but that's okay. All right, so hopefully you do remember the quadratic formula. If not, here it is. So, given this quadratic equation, ax squared plus bx plus c equals 0. So we have these numbers, a, b, and c. The quadratic formula tells us that if you're trying to solve that, then x is going to equal to negative b plus or minus the square root b squared minus 4 times a times c all over 2a. If you don't have this formula memorized yet, I highly recommend that you do, so that when you're solving quadratics here in this class or in calculus, you don't have to bother looking this up. Okay, I use parentheses here to make sure that you know what you're multiplying and what signs you're going to be using for each one. Okay, so it kind of keeps things organized when you start plugging them in. All right, so let's take a look at this example. So let's go ahead and solve x squared plus 5x minus 6 equals 0. All right, so here we see that a is 1, b is 5, c is negative 6. Okay, so this is what we are going to be plugging into our formula. Let me kind of bring this down a little bit. All right, so according to the formula, x is equal to negative b. B is 5. So we'll place 5 inside there. Plus minus square root. And then b squared. So again, b is 5. So inside here we'll put a 5. Okay, and then minus 4 times a. What's a? A is 1 times c, which is negative 6. Okay. All over. So make that nice and long. Make sure it's everything. All over 2 times a, which is 1. Okay, so that's plugging all of the numbers into the formula. So now we will go ahead and simplify this. So we get negative 5 plus or minus square root of, work this out with me, 25. And then do all of this multiplication, these three numbers here, negative 4 times 1 times negative 6. So that's going to be plus, and that's going to be 24. All over 2 times 1. I think we can all do that. All right. And then let's simplify this more. So negative 5 plus or minus the square root of 49. Hopefully you all know what the square root of 49 is, so we can simplify this some more. All over 2. Okay, so what's the square root of 49? Hopefully you said 7. Okay, so right here, you do not leave your answer like this, especially if you have a perfect square. Okay, so in this case, if let's say that said square root of 47, then fine, you leave your answer like that with the square root 47. But because the square root of 49 is 7, we could actually work out the answer to this. Okay, and we have a plus minus there, so we're going to do 2 problems. Okay, we're going to do one here where we do negative 5 plus 7, and then we're going to do another one over here where we do negative 5 minus 7. Okay, all right, so let's start with the negative 5 plus 7. So negative 5 plus 7 divided by 2. So that's 2 over 2, which equals to 1. So that's one of our answers, x equals 1. Okay. Now down below here, let's do the negative 5 minus 7. So negative 5 minus 7 all over 2. And that gives us a negative 12 over 2, which is equal to negative 6. So that would be our other answer, x equals negative 6. Okay. All right. Perfect. Okay, so those are the 3 ways to solve quadratic equations. Quadratics are degree 2. Okay, so remember quadratic equations. This is a linear equation. Okay, this is linear. It's degree 1, which means the exponent on the x is no higher than 1. Okay, and quadratics are degree 2. The highest exponent on x you'll see is 2. You won't see cube and whatnot. Okay, so this is a quadratic. Okay, so you all know how to solve linears. We did a quick review here on solving quadratics. So now what we're going to do is we're going to take a look at equations that are higher degree, but it turns out that their form or their structure is quadratic. Okay, so let's take a look at quadratic in form. Okay, so quadratic in form. So not quite a quadratic because it doesn't have that restriction of having degree 2, but its structure is like a quadratic. So if a quadratic has this form, this is a quadratic. Okay, so if this is a quadratic, then what happens is for something that's quadratic in form, what happens is, I'll show you in a second. Let me just put down almost identical. So what happens is this middle term, bx, the x has some sort of an exponent. Okay, could be 3, it could be 5. And then over here, the ax, the x over here has 2n. Okay, so if x in the middle here has exponent of 5, then the first x has to have 10. Okay, you'll see. Okay, so let's solve this one. X to the 4th minus 13x squared plus 40 equals 0. Okay, so when we look at this, this is not a degree 2, it's a degree 4. So this is not quadratic. However, this is quadratic in form. So that's what I'm talking about for this one up here. Quadratic. It's not quadratic, it's quadratic in its structure. So we say it's quadratic in form. Okay, which is this one, because we see here in the middle, x has a power of 2. And then over here, x has a power that is twice as much, which is 4. Okay, so when you have that, then you could treat this like a quadratic. Okay, and you could use those 3 methods for solving a quadratic for this one. So let's go ahead and use factoring. Okay, but instead of using x times x, because x times x makes x squared, here we need to make x to the 4th, so we're going to do x squared times x squared. Okay, and then everything is the same after this. So we want positive 40, so the signs will be the same. We also want negative 13, so the signs will be both negative. Okay, and so the numbers that make 40, we can do 1 times 40, we can do 2 times 20, we can do 4 times 10, we can do 5 times 8. Aha! So 5 times 8 works. Because then we get the negative 13 in the middle. Okay? All right, and then we use the zero property rule. Something times something equals 0. So one of these factors must be 0. So let's take each factor, set it equal to 0. Okay, add 5 to both sides. Take the square root. But when you do that, you have positive, negative. Okay, so here is our first 2 answers. And then over here, add 8 to both sides. Take the square root of both sides. And when you do, you get plus minus the square root of 8. We can simplify that because this is the same as plus minus square root of 4 times square root of 2, right? Okay. Waiting for the screen. Okay. And then that gives us plus minus 2 square root 2. Okay. So that's it. So if you see something that is not a quadratic, but it kind of looks like one, then you can use those methods as well. Just be careful to do the necessary x squares here. Okay. All right. So I think that is it for this section. It is. Okay. So again, if you have any questions, make sure you message me or email me. Have a great day.